Hello, good morning, good evening, everybody. Thank you for joining us here at LabConco with our virtual freeze-dry training class. We hope you enjoy what we're about to show you and teach you. You can put it to good use. My name is Joe Reichert. I'm one of the service advisors here. I'm sure many of you have seen me and or talked to me in emails, but I have been here for just over 15 years now and have dealt with the freeze dryers for almost that entire time. Right now, you'll notice that everybody is muted and their cameras are turned off. We did that to help having everybody on the same meeting at the same time. It also helps keep the background chatter and noise down. But I will show you how to go through freeze dryers, how to vacuum leak test. We'll also go through a triad a little bit as well. Taking them apart. It's going to take some time for the next 2 hours to do this. So as we try to go through it quickly, we have also removed some of the screws and some of the panels to try to make it a little bit faster as well to try to get through with it. The meeting is also being recorded, so that's also a reason to turn everyone's cameras and everything off. But this will allow us to also be able to send the link to anybody. If you want to have a copy of that, we can do that. Is everybody in? We're okay to go ahead and begin and start. My boss Kurt is my cameraman. Check and make sure everyone's logged in. And by the end of this, if you do have any questions during or even after, make sure to take note of those, write them down, and you'll send them to your regional managers like Mauro, Eric, Durai, and other sales people within our company. Just to go through some of the basic tools that we'll be trying to use today. Just your standard like Phillips screwdriver. We have a 5/16 nut driver. That is about our most common screw that we use on anything. We do have a few different ones though. There's the 3/8 that we'll need on the Centrovaps, and your standard pliers, maybe some needle nose. You also need a small Allen screwdriver or Allen wrench to get those knobs off of the triad. Show you what people actually do use the valve wrench for, what it should be used for. And then your drill, vacuum gauge. We also have a specialty tool that we kind of made ourselves. This really helps with our getting the nuts from the chamber on the roof of the freeze dryer. It's a long reach in there sometimes, and on the 2.5 liter machines, it is very small to get it along the sides. So it is basically just a 7/16 ratcheting wrench welded onto a steel rod, just so we can reach in there. Something simple to make. Also have a 12-port chamber and some of the items that we use for troubleshooting with vacuum leaks. These are just the parts that come with your chamber. And we'll get started with how to maybe update software on your freeze dryer. All you need is a flash drive on anything currently made since I think our last, when we went to LioWorks 2, we were about 2020, I think, when we went to the LioWorks 2 version. If you have an older version with LioWorks 1, it does take you to have to go to our website to get some different files. But if you go to our website, I'll show you where to get the files at. You just go to labconco.com. You go to the resource page right in the middle. And in your technical resources in the center, you go to software and apps, filter it by freeze dryer. And these are the only 3 files you'll need. And if your unit is new enough to have the LioWorks 2, you only need the bundle file. You just gotta open it up, download the file, and you just drag this file to something as simple as a flash drive, and then you would stick it into the side of your freeze dryer. And I'll show you how to do that here in a second. If you have LioWorks 1, you'll know that by going to the About page on the screen, and you're going to be missing some extra writing. You won't have update buttons. Those you do have to start with these other 2 files first before you use the bundle file, so that you can update the operation software to the LioWorks 2, and then you could use the bundle file to update everything else. When you have an accessory mounted to it, similar to a small tray dryer or a stop ring tray dryer or a heated shelf, anything that has a board or program to it, it will also update it at the same time when you use the bundle file. Okay, so now let me show you how to put that onto the freeze dryer itself. So here we have a freeze dryer, the 4.5 liter -105. I have it plugged up off the top for our vacuum leak troubleshooting. But if you don't know if you have LioWorks 1 or 2, you simply just go to the question mark, go to the About page, and this unit has LioWorks 2.0 because you can see it has all this writing here down below. You also have some things like the update button and check for update. These items you wouldn't have on a LioWorks 1 version. So this model, before you can do a USB update, you have to go through the instructions that are within the files online to be able to update to the LioWorks 2. It just takes a laptop with an Ethernet cable plugged into the back, and there's some other instructions on static IP addresses and things like that. But I have those broken out in different directions to make it a little bit simpler to do. But on this unit, it's got the 2.0. So all you do is just insert your drive into the side. You'll get a message on the screen that'll say USB accepted. Just press OK. Go to your About screen, press Update, and there's your file right there. All you do is touch that file, and it'll go through the update screens by itself. This takes a few minutes to do, so instead of having the machine do this, it's already updated to the full software. I'm going to skip actually going through, as it takes several minutes for it to go through. Less than 5, but it's still just a time that we can do something else. On the screen, you also have your diagnostics mode where you can test a lot of different relays. This unit doesn't have any accessories to it, so there are no other options besides the 4 that you see. You can run an auto diagnostics mode. It just runs through all 4 of them step by step, where you can then take it and export it to a USB drive if you needed to. The unit does have a power monitoring board, so it will tell you what your voltage is going to the units and how many amps are being drawn. This being a 2 compressor system and 115 volts, we run a higher amperage here in the US versus the 230 volt models. But when you turn on your vacuum pump, and everything's added in there together. You can also troubleshoot things like, is your vacuum pump maybe over or pulling too many amps, maybe popping the breaker on the back of the machine. You can always go and just turn on your vacuum pump. Like if I turn off the refrigeration, stop that, and then if I go back to the diagnostics mode, and now it shows me that I'm only pulling 3.3 amps. I have a scroll pump connected to this unit right now, and so they don't run at very high amperage. But to try to do troubleshooting on these units, I'm going to stop the vacuum pump for a moment here. And then I'm going to bleed the pressure out from the side. Since I have no chamber on top, I'm just going to use the drain port. Okay, so now I can remove everything off the top. And we can always install the 12-port chamber. But the one thing we never know where the leak is it in the chamber or is it in the freeze dryer? So the first thing to always try to figure out is, where do I need to spend all my time? You may have a vacuum pump that's not working properly, which if you don't have a vacuum gauge, you can easily get one and test your vacuum pump. If the pump is the issue, you might spend several hours trying to find your vacuum leak and not realize that it's actually just directly in the pump itself. So if you used this is a fitting that we have in the freeze dryer. It's in the very back, and we'll see it here in a moment inside the machine. This is what has your vacuum release valve, has your vacuum sensor, and it plugs into the back of the chamber in the machine. So we take these, it fits directly onto the hose barb or the hose adapter of your vacuum pump. If you take the pump hose off, and we have our vacuum gauge here, has a sensor on it that we can insert into something like this port on the side. You just insert it, stick this on top of your vacuum pump, and then you could use a rubber stopper to plug the top of this. And now you have a perfectly sealed coupling that you can measure your vacuum pump directly and accurately to know, where is my issue. If your vacuum pump doesn't pull, below a 1 millibar, or it should be able to get to a 0.0 millibar in less than a few minutes. If it's slow or having trouble getting to a low vacuum, then there's no need wasting your time of trying to figure out if there's a leak in the freeze dryer when it's the actual vacuum pump. But we know this vacuum pump works good. So we're going to go through more troubleshooting without that. But first, scroll pumps are our newest pump that we carry, and there is some setup to a pump when you have them new out of the box. So they have to be put into an auto mode. If you've ever installed one and noticed that as soon as you turn power on the freeze dryer to try to turn on the vacuum pump, it won't turn on. All you're getting is a light on the interface of the pump, and then it doesn't turn on. So you either hit the green button and turn it on, but I'll turn on the vacuum pump so that we can get the light to turn on. If you notice, the light's on, but the pump did not come on. I know it's hard to hear it with my earbuds on. It kind of takes away the background noise, but it is not on. So to turn it on and to put it into auto mode, you'll see a little indication here that says auto, and then there's a light just below it. To turn it on to auto, you press and hold the green button or the red button. You could do either one. You hold it for at least 8 seconds, and then that light will come on. Because I'm hitting the green button, the pump did come on its own. But if you continue hitting that, then the light comes on. And now this pump is ready to use with the controls of the freeze dryer. I'll turn the freeze dryer controls off on the vacuum, and how that turns on and off the outlet in the back of the freeze dryer. Turn it back on, the light will come on, and then the pump will start back up again. Easy operation on those pumps. The vacuum pumps do need to be purged and maintained, even though there's no oil in them. But you should always purge a pump for about 20 minutes after every drying run. And that just takes opening the gas ballast on the side of it and leaving it open for a minimum of 20 minutes. Helps with clearing out any vapor in the pump, any debris that might have gotten into a pump on a scroll pump. Since there is no oil, there's nothing in there to kind of take any of that vapor or moisture. So you need to clean them out. And the same thing with an oil pump too. Rotary vane pumps need to be purged as well. You'll extend the lifespan of the oil a long ways by doing that. So on the freeze dryer itself, I have here, I'm going to stop my vacuum. And all I have here is for my leak testing here is a couple of gaskets, a spacer that comes with your chamber. And then we have these little plugs as well that we have here. These work nice on covering up the top of the port. They can also work on consoles as well, covering up those. But inside the chamber, obviously you have just the coil. We have our steel lid that came with the unit. And we just cover up the top, make sure our gasket slides inside the top of the chamber. For this type of testing, you really only have to have one gasket if you want to. You can use the plug, or you could use a 600 ml freeze dry flask. These have a rim of the mouth that's big enough to fit right on top of that gasket. And then with this type of test, you do want the cooling on, since you are going to be pulling vapor across a coil. So you have room vapor in the room that could get in your pump. Won't be much, but it's always best to keep as much out of it as you can. Then you just turn on the vacuum. The flask will take all the pressure that you can handle from the pump. There's no difference in having the flask here or on your 12-quart chamber. It's all the same pressure. You see, immediately it's held down. And here you should get a pressure on your display in just a few seconds to maybe a minute or two. I turned my collector off, so it's gotten warm in there, so it takes it a little bit more to get there. But if you get a vacuum like this, then you know the leak is going to be within your 12-quart chamber. And we do have a video on our website that shows you how to troubleshoot a 12-quart chamber, how to take apart the valves, and how to re-grease them. Dan Heck, our design engineer, did that video for us. But if you don't get a vacuum like this, then you could still possibly have leaks inside the chamber, or it could be from your drain port itself. Now, obviously, I'm getting a vacuum here, but if I did not have a vacuum, I can take my silicone hose that comes with it, and all you do is just bend it over and kink it like this. You can just hold it by hand and then insert it into your drain port. And I shouldn't lose any vacuum except for the little bit that was in that hose. And then it's going to come back down. But let's say you did have a situation where your machine was at high millibar and you inserted your drain insert with your hose kink like this, and now all of a sudden you're getting a vacuum. Well, that means your vacuum leak was in your drain port, and you change that part out and you should be ready to go, ready to operate the unit again. Pull this back out. So if we did not get a vacuum from either one of these tests, then the vacuum leak would have to be within the freeze dryer itself. So then we're going to take off our pieces here. We no longer need the collector on anymore. We're not going to pull vapor through it. But then you would use just rubber stoppers like I had before. These are just number 1, number 2 rubber stoppers. They have numbers right on the end of them. It's kind of hard to see since they're black. A little bit of different sizes, but the number 1 or the number 2 fits. All you do is stick it right in the back hole, just like that. And then you turn on your vacuum. And you should get a pressure almost immediately because all you're pulling a vacuum on is the hose. The pump came on. And now we start to get a reading fairly fast. And the only other spot within the chamber that could leak would be underneath the coil feet. And there's O-rings down underneath here. That takes having to remove your refrigeration lines from the bottom, removing the gas from the system to change out the two O-rings from underneath there. That's a pretty large job to do. Luckily, it's not something that we see very much at all. It's a very seldom thing you would ever see from that. But you can get holes in your chamber. This is a PTFE coated chamber, but we do have the stainless steel, and we sometimes have customers that will put acids in those or some kind of corrosive that might eat through the steel or pit the steel. You can get leaks like that in there as well. But also, you're not going to be dealing with just a vacuum leak on that. You're going to have a coolant problem on that machine. Okay, turn this off. Now, something I usually like to tell people on freeze dryers and tell all of our service engineers is that a CentroVap or a freeze dryer or a CentroVap both only do two jobs. They are supposed to get cold or heat, like in a CentroVap or on shelves of an accessory, and they're supposed to hold a deep vacuum. If the machine does both of those, then it is doing its job. If a sample is not drying properly or not drying correctly, there's some other force that is making it not dry. Samples in a flask hanging outside a 12-quart chamber, maybe it's in a window. It could be getting heat from the sunlight coming through a window. I've had samples that are sitting above the vacuum pump, sitting right next to the machine on the side, and the heat that's coming off of that ends up affecting the samples. But the freeze dryer, again, only cools and it only holds vacuum. Those are the only two jobs we can ask for it to do. So as long as it's doing those two, the machine's doing its job. Now, on the cooling side, if you have a machine that is a minus 84, for example, and it's cooling too much, I've had customers believe that they have a machine that's working really good, so they think it's not a problem. So if it's getting to minus 90, they believe it should be working great. But unfortunately, that's actually a issue of maybe slightly short on charge. Very small amount of gas needs to be added to the unit, because even though it's cooling really cold, it won't be able to handle the heat load when they start adding samples to it. So when they get start loading up their flasks and putting samples on, and the temperature starts to diminish, then we'll know that they probably actually have a little short on gas, and then we need to check the gas charges. I know you guys all look through the guides that we sent out, and explains how to use the thermocouples, how to use those temperatures to decide if you need to add gas or maybe even remove gas on some of these one-stage, single-stage systems, or even the two-stage. We have pictures in there for all the process valves and the gas charts. But I will say that on the gas charge, I always use the one that's on the back of the front panel. That is always the most accurate one that's on the units. And just so on this unit, we will take this off. Usually has 3 screws, but again, like I mentioned earlier, we started removing a lot of screws to save some time. I don't think anyone has any trouble learning how to remove a screw, so we did most of that ourselves. So on the back of the front panel, you will see your gas charges for your first stage. This is a bit of an older system. So it still has 507 in the first stage. And then our R1150 in the second stage for the -105s tells you what pressure it was charged to, the suction, and tells you the same thing on the first stage as well. It also gives you your GWP numbers. I've had some customers request those, but those are listed right on the stickers as well. Your global warming potential numbers. Now there's changes within that on gas as well coming up, so probably more changes of gases. On your wiring diagram, fairly small. If you have issues trying to see it, there is a part number right here on all of our wiring diagrams. So if you tell us what unit it is, we can find the wiring diagram. But if you give us this part number, we'll be able to go right to it, and we can email you a normal size wiring diagram so you can maybe zoom in and see it a little bit better. But these units do have are on these wiring diagrams. It does give you some helpful part numbers in here for like your temperature probes, your vacuum sensor. Tells you your PC board part numbers. Really hard to see in these small prints, but some of your harnesses also has part numbers for your harnesses going throughout the machine. So if you need a harness, something became disconnected, then we can get part numbers directly off your wiring diagram. Okay, now we'll remove one of the sides. I'm going to also unplug the unit. It's always safe to not have your power on while you're working on the unit. Pull the unit to the edge, and then we can get to the screws on the side. There's normally 4 of them on the side here, but I think we took 3 of them out already. Same thing on the left side, right side, depending on which way you're facing on it. Pull it to the edge. You can get to these screws as well. On the back of the unit, we have a few more screws. But also like to point out on your vacuum hoses, you can get a leak at your vacuum hose if you put the clamp right over a slit that we put on these hoses. So you take your hose off. There is a little cut in every one of our hoses on both ends. Sometimes the cut goes deeper, but we try to make it as shallow as we can. Because of the wire reinforcement running through the hose, when we cut the end of the hose, there's always a sharp piece of metal that would be coming out right about there where the wire would come out. So we trim down and then we pull out the piece of wire so that customers and installers and everybody doesn't cut themselves on just the piece of hose. So when you clamp, you just don't want to be at the very end of the hose. You want to be backed off of it just a little bit. You'll be fine. Rear panel has a lot of screws in it usually, but we took a lot of those out. On the back side, this is where you'll see your condenser. You also see your power box has a few relays in it, has your power monitoring board, has your power supply board, and then you also have your heat exchanger on your -105 back here. Up on the inside is where we have that 4 rubber coupling that I was showing you that we use for vacuum leak test. It also has your vacuum sensor right here on this side, the little gray body. And then you also have your vacuum release valve on the other side. It's easy to see it because it has the white little filter on the end of it. I do get pictures of that a lot from customers and service providers looking for the vacuum sensor, and they send me that picture thinking that that's the vacuum sensor, but that is not. It is the vacuum release valve. And it is possible for that valve to leak. It's supposed to close as soon as you turn the vacuum on. It can stay open if it is broken, but you'll know that when it's broken. If you can't get a vacuum, if you put your stopper in this hole in the back and you still can't get vacuum, but you know your vacuum pump is good, well, your only two options at that point is either the vacuum sensor or the vacuum release valve. And sometimes if you just feel on the very edge of that filter on the vacuum release valve, you'll feel air pulling through it if it's what the issue is. So now on the front of the machine is where we have all of our process valves. They're all labeled. Your stage 2, you have your suction, you also have a discharge. We don't really, I don't have a recording of what the discharge pressures are. We just do mostly suction on everything we use. Even when we're building the units, we use the suction pressure. But there is a discharge valve. The reason why we have both of them on a minus 105 is we charge it from both sides, and it's faster for charging it that way. Now on your front panel, to remove it, we just have a couple screws. And then your panel will come down. You have a few wires in here. Disconnect your USB cable. This wire is for your sensors. Try to get in. I have large hands. Sometimes it's a little difficult to get into here. Get these off, but I can manage. All of them go to their own home. There's no other spot. There's no other harness that's alike. They are all separate, except for the vacuum sensor. Okay. Now the vacuum sensor itself is a micro USB connector. It only goes to the USB connector. Now there are two others. There's one here and there's one here on the BeagleBone board, but it does not go to those. Those are only for programming purposes. And this is where it fits into. Tells you that on the wiring diagram, tells you where it connects. And if you ever take it apart and you put it in the wrong spot and you turn everything on, all you're going to get is dashes for your vacuum. Now, when removing the PC board, there are some of these larger screws. These hold the board assembly together, so you do not want to remove these screws. You only want to use the small ones down inside the holes. These are the ones that hold the board into the control panel. Okay. If you do order a new board, it is always best to update the software after you receive it. We have hundreds of them in stock. So if there's a software change, the chances are they're going to be not updated to the most up to date. Whenever we build machines, we obviously update everything before it goes out. But if you order a board, we don't really have a way to pre-program those. They'll still have a working software on them. It just may not be to the full up-to-date mode. So on the inside of this unit, to take the wrapper off, we've already removed all the screws from the side, but we have 6 screws that are attaching the chamber to the wrapper. If we look up inside here, right here in the front, 2, so there's going to be 2 in the back, and then there's 1 on each side. These side ones are the ones where this tool really works well for us to have to reach all the way back in here to get to it. So I will remove these. Trying to remember which way that goes. And these screws are all lock nuts. So you do have to take them all the way off. You will see the chamber starting to drop down. Which is why we really can't take these off before class. Now, another possible scenario for a vacuum leak I've seen on some older systems, or maybe you have a stop ring tray jar on a console, something that's heavy, and somebody landed something on top of the rim of the chamber. If you could see right here, there's a gap between the chamber and the upper wrapper. See how I can push this down? This rim has to be up above the height of this wrapper for our gaskets to seal from our chambers, from our small tray dryers, things like that, have to seal to this edge. What can happen is these studs underneath are welded on the bottom. And on our old systems, we only had 4. We had 2 in the front and 2 in the back. Now we do 6, so it's supported more. But if you had a threaded stud break off or pop off the weld, then the chamber might sink down inside, and that will not seal for a chamber. So you always want to make sure that that rim is up above the side of the chamber. Inside the machine here, we can also view our thermocouple wires. The purple ones are the thermocouples that go to the suction lines. The brown one is the one for your display. We've only used type T wires, and so your meter has to be set up to read type T. And when you're use these wires here to make sure your display is reading correctly. This brown one goes directly to the temperature sensor that's on the exit side of the coil. And these are going to the suction lines from the compressor. So you use those for diagnostics for your refrigeration, and the brown one for the display to make sure it's reading properly. The thing I like to explain to people while I'm doing all these screws here is our display and how it operates with the different colors and the temperatures. We get a lot of customers who want to see that -84, they want to see that -102 or the -50 in their freeze dryer. But we put our temperature probe on the exit side of our coil. So it is taking the warmest reading in the system The coil is actually going to be colder than what our display says. But while we take that reading from the exit side of the coil, we're going to know when the system is starting to get overloaded with sample. And so a customer's unit doesn't have to stay at minus 84 or minus 50 or minus 102 to be actively working. All that's telling them is that they are starting to add a little bit of load to the system, and it's going to start to warm up a little bit. So when the customer has to know what the freeze point of the individual pieces in their sample are. So they could have water and acetonitrile. Acetonitrile freezes at minus 42 C. Water is, of course, at 0, but the mixture may freeze at a higher temperature or at a lower, temperature in between there. But when you're vaporizing samples, the vapor is vapor. It's 100% acetonitrile. It's 100% water. It's whatever's going in it. And your collector has to be cold enough. So the proper coil temperature to collect any sort of sample has to be 20 degrees C. Below that to freeze it. That's why we don't do acetonitrile in a minus 50. Well, we can do it at a minus 84. But again, when your samples, your display is starting to warm up, we don't turn red until minus 75. And then we don't alarm at you to tell you that there's a temperature issue until you get all the way down to minus 40, because there are some samples that you can still, as long as the freeze point of those individual components in that sample are freeze at minus 60, then I'm sorry, minus 20, then you're okay to still collect them at minus 40 as long as the freeze point is minus 20 or more. So that helps, it should help a customer understand how they can still load more samples. A lot of customers get afraid when that number moves or changes and they don't want to add any more sample. But as long as they're doing something like acetonitrile, they're okay to warm that chamber all the way up to minus 60 before they are going to have any issue with bypass into the pump. So they might as well keep adding so they can use the capacity of the unit the way it's made. Like an instantaneous capacity on a 4.5 liter minus 105, I believe is 2 liters. And the way we test that is with water, since that's the most common substance there is for us to test with. But we will take a liter containers at a time, shell frozen, so that we're hitting as much vapor into the coil as we can. But we keep adding sample and adding flasks until we get that unit to reach its alarm point at minus 40. So it's not going to hold that temperature of minus 84, minus 102 all the way until that instantaneous load. We're loading it until it goes into alarm. There we go. I got that last nut off of there. Okay, so now I can remove the wrapper. I got all those screws off. Oh, I forgot one more thing, sorry. There is a 1/4 inch for the vacuum port. So I need to be able to remove that clamp before I can move the wrapper. And you just want to be careful. Sometimes this is probably easier done before we remove the wrapper. But it just pulls off just like that. Now we can remove the wrapper. Much easier now. Now inside the machine, we can see our cooling fan. I've seen cooling fans get stuck up in insulation, or maybe even getting too close to the condenser itself, seen it hit that. But it's usually like sometimes you'll hear a wire getting hit by that fan blade. Um, this is our defrost valve after we made the update in 2016, 2017 to our new style units. Every unit now has a defrost valve, a hot gas bypass so that we can melt ice off of our collector easier. Filter dryers, and this is a good look at the 4-port piece that I was using earlier for the vacuum troubleshooting. Has the vacuum release valve, vacuum sensor, and the back port on there for your vacuum hose. On the side here, this is your cap tube assembly. Inside this insulation goes up through the coil, and it actually ends right about here on top of the coil inside. That's where the coldest point of the system is, right where that enters into there. And then an oil separator. This unit is a few years old to have the bigger oil separator. You would have to make sure you add plenty of gas to make up for oil absorption or gas absorption in the oil with these bigger oil separators. So if you recharge a unit that has one of these oil separators, make sure you give it enough time for the gas to soak into the oil. Run the unit for several hours, turn the unit off, let it rest, turn it on, do that cycle for a couple of days actually, because it'll take a while for that oil or the gas to absorb into it. Once it reaches its equilibrium of absorbing into the oil, then it'll be a normal charge after that, and you'll still be able to measure your pressures. The electrical box on the back does come off as well. It can come off with the back panel or with the whole wrapper on. It is much easier to get to it this way, but you just have the one screw here. Then the box has a hook on the bottom. It pushes back and then up. You can see on the bottom side, you got this hook that goes down through the frame of the unit, so it stays stabilized in there. But here you have all your relays for your vacuum pump, compressors, the machine itself. Then you have the power supply board on top, and then the power monitoring board underneath. Power supply board is what powers your display board. And your power monitoring board is like what I was showing you earlier, shows you all your different voltages and amps on display. So if you get to a unit that is not, say you have a stop ring tray dryer connected on top, but it's not showing any voltage for it, the machine might give you an alarm that says accessory power switch not turned on. And that means it's not registering the power from that unit in the bottom base unit. You might have a power monitoring board issue. But that's about it on these units. This is also a piece. We have the pressure switch that is there for between your first stage and second stage. If the first compressor does not cool the gas enough of the second stage, then the pressure will be too high within that second stage. So this switch will shut the second system down if the pressure is too high. And that's about it on our benchtop models. Roll this out of the way. And now we have our triad. Much larger machine here. Vacuum leaks on it. You still have the 4 valves on the side. Your door is going to be your biggest portion of a leak. If you have an issue where your pump's on and you can't even hold enough vacuum in here to hold the door closed, the pump's on and everything just still opens up, you either have these valve open or your door gasket is not sealing against this metal edge right here. The gasket could have a roll in it. It might be flat over here, but maybe have a hump in the middle or something, keeping it from sealing. But you can also check to make sure that your the issue is in the chamber just by moving your drip tray in the baffle. Then there is a shelf support, it slides out as well. And in the very back, there is a hole all the way back here. And that's the same hole that you have just like on the console model, or not the console, I'm sorry, the 4.5 liter. You do have them on the console. It's the same size hole. You can still use that #1 rubber stopper. You can get it all the way back in there, stick it in that hole. And when you turn that vacuum pump on, you should be able to get a good vacuum. If not, then your issue is going to be on the other side of the chamber. It's going to be on the outside, where we have another one of those 4-port rubber couplings, vacuum release valve, vacuum sensor, all that is on the back side. If you think the leak is going to be from the door, you can do a leak test with just a piece of paper. And the way you do that test is you can slide it behind the door, close the door, and it should be so tight that it's not going to come out of there. But you can do this test all around it. Hinges are kind of more your susceptible area, easier spots to have leaks because these are adjustable back and forth. You can also do it around the latch. Test it the same way. It's all tight. But this unit we found actually has a spot at the top. See how easy that slides out of there? Shouldn't be able to push the paper through the gasket. So we believe on this unit, it actually has a bowed door. So the issue isn't with the gasket or the frame, it's the door itself. And you can slide that through there. It shouldn't be able to do that. So this would probably leak right there at that spot. If it's just a slight, you can almost get enough pressure just to push it. As soon as it grabs the seal, it could bend that acrylic back in there. And it might bend it back. Inside the unit, you have your shelf mechanism here. It pulls down. You can see your bladder on the inside there. Just pulling down on these rods. There's 4 rods in here. You can get to the bladder this way. If you take some wood, like a 2x4, I'm not sure what you call that. But if you turn it on its side, you can actually prop this piece down. This is all spring loaded, so it's pretty tough springs. But if you stick a piece of wood back in there, you could prop this up to be able to get the bladder out, to be able to change it. But it is going to be probably easier to just pull the whole mechanism out. Now in the back, can't really pull this too far out because there is some wiring. You have the wires for your sample probe. This unit also has a level sensor so that if somebody puts vials only on one side of the shelf, and then as that shelf comes down, if it starts to tilt, well, it's going to knock those vials over. It's going to break vials. So you don't want it to do that. So the machine will stop the operation of that when it gets more than a 5% of a turn. And it'll open a valve that's behind this panel to release the air out of the bladder so it doesn't continuously try to pump it up. It's not a pneumatic system, so there's nothing actually physically pumping air into the bladder. It's just your atmospheric pressure that when you turn your knob to raise or lower your stopping mechanism, it's just going to pull air from the outside into that bladder. Because while your chamber is being evacuated to a vacuum, so is the bladder at the same time. If you have a unit that the bladder starts to open up and expand when you're not asking it to, then that means you have a leak someplace in the system, maybe in a valve, could be a pinched hose. If somebody had possibly, maybe the customer pulled out their stopping mechanism a little bit because they had a vial that slid off in the back and they want to try to clean it. Maybe they broke some glass and they're trying to clean it out, so they want to try to pull this out. Well, when they pushed it back in, they may have pinched that hose whenever they were pushing it in there. So you might have to check to make sure that hose is straightened out, because if the hose gets kinked, then it's not going to be evacuated as with the chamber when it's being pulled under vacuum. And that ends up with two different pressures inside the bladder and inside the chamber. So the bladder will start to open up because it's not as a low pressure as what your chamber is. So that's a sign that you have a hole in the, or a kinked hose. The other thing we have seen is we've seen a few bladders that have a leak. If you have a situation where the customer's vials aren't fully being stoppered, then the issue could be that the bladder has actually a leak in it. So as the air is trying to go into it, it can't fully inflate that bladder because it's got a leak. So when you're running the system and you turn on the stop ring, your vacuum on your display shouldn't go away. It should stay at the green level. It might change a few decimal points, but it isn't going to go away. If you open up your stop ring and you go to raise or go to lower to make this come down, and your vacuum goes immediately to high millibar, then you have a bladder that has a leak in it. To pull this chamber mechanism out, like I said, it's just pulling, but you got to have the wires here. So you just want to make sure that those wires get disconnected. There's a pass-through in the back, top left corner where they plug in at. And then you have the hose from the bladder that's also on the back, and it just slides off the pole in the back. There is a little spring clamp on there, which you'll see here in just a second. And you also have a temperature sensor. I forgot to pull off here. And trying to get that separated. Kurt, could you come and separate those? I can't get that with one hand. Yeah. Pinch that little trigger. Other way. Pinch that side. There you go. There we go. Sorry, I was being a little stubborn. I should have thought about that one. So with our mechanism, we now can see the bladder hose on the top. And this is a little spring clamp that holds it in the back. You just pinch it to release it. And this is what plugs into the hose. You have a couple of harnesses here. This is for your sample probe from up in front. And then on the inside, you really don't have anything, but this rod here on the left, this connects to the sensor for the level. Because once this platen comes down, and if it turns, the bar will hit the metal of this and ground it out, and that's what sets off the alarm. And to try to get the bladder out of the top, you just have to remove the screws on the very top of it. Be careful, as I mentioned, it's under spring tension. So taking that top off, you want to make sure it's being held down, and then you can slowly release it. Inside the unit, you can see the pole, the pipe in the back. That's where the bladder was attached. And then to the left is the pass-through board there where the wiring harnesses were connected to. Then we also have the sensor that I forgot to disconnect. Is the sensor that is plugged directly into the back of the chamber. And what that sensor does is it's going to be the temperature that the display takes its reading from whenever it's in max cold mode. So in max cold, it only uses that temperature sensor. When you're in any other mode on the unit, it uses a different sensor that's on the back of the unit that we'll see here in a little bit when we take it apart. But that one is on the Lexol line, just to the left of the heater. So when you have customers that are using max cold to pre-freezer samples and it goes to -75, it removes all the gas from the collector and shoves it into the shelf. So your display reading will have dashes for the collector during max cold mode. And then your shelf is to get to -75. Whenever the unit transitions between max cold to the next segment in the program, you'll generally see a jump of temperature because we are transitioning from this temperature sensor that's in that really cold shelf into the sensor that's located in the very back of the unit that's measuring the Lexol line. The Lexol line isn't going to be as cold as the shelf, but so they could see a 20-degree difference, maybe even a 30-degree difference in temperature when it transitions between modes. But as soon as that Lexol starts flowing through the shelf, it'll quickly get the temperature and show as normal to whatever temperature the customer is using at the time. So take this unit apart. I'm going to take off the two knobs. There are set screws on these knobs, but again, for speed, I loosened them already, so they just come right off. I have had customers ask for these knobs. We don't sell just the knob. They come with the valves, so we don't have an option of having the piece for it. So if you need a knob, you have to order a valve to get that. On our front panel, we again would have 3 screws across the bottom. Again, we took most of them out. So I just have the 1 screw. And the unit might be. Back in there a little bit far. I had to pull my. There we go. Now the front panel comes off. I'm going to take the control panel off. There's a couple screws here, and there's a few more that are back inside these oblong holes that holds a little clamp here. So those don't need to be removed. They just need to be loosened themselves. Get to everything. There we go. These all have the same connectors. Every unit looks very much alike. To take the side panels off, though, you have to remove the USB cord because that connector is attached to the sidewall. But there's enough wires here that'll really hold that in place. Valves, they just twist and pull out. Nothing holding them really there. Give a twist and a pull. This unit's got some age to it. You can see the vacuum grease kind of changes colors on you after a while. And On the back, now normally in the backside, there is a piece of foam insulation back inside here, but of course we took it off so we can show you access to the rear of the unit. So again, this panel will sit just like this on the backside, covering it up. It has to be completely sealed in the back from air getting in here. Even though these pipes on the inside are already insulated, it gets so cold that you will still get a ball of ice. I've seen this entire area full of ice before. And then when your customer shuts the unit off for the nighttime, it'll defrost and then it just drips water on their counter. Doesn't really get hurt anything as far as the machine wise. All your components are up off the ground. There's no wiring that's really going to get into, but it can cause a mess for your customer. I know they don't like to see that when they come in with some water on their counter. The black wire here, this is the wire that I was referring to as the temperature sensor. All of our units use the same type of temperature sensor. It's a RTD, 1000 ohm RTD, but it's always this black braided hose or braided cable. And this is where the temperature probe actually is. It's right on the Lexol line. This is the heater right here. And then your temperature sensor is right on the Lexol line. It's coming out of the heater and then goes right into the shelf. So that's where our display temperature thermocouple is. Remember, the brown ones are for your display. Blue ones are for your suction lines. So these are the lines, again, that you would use for making sure your display is good. I have had some where we had a vacuum leak on the unit and actually took until found out these clamps right here had gotten loose. Both clamps there were loose and allowing it to bleed air there. So that's a spot where it's possible. You hope you don't have to get inside the insulation just to find a vacuum leak. But if you block everything off from the inside and you still have a vacuum leak someplace, even after putting the stopper in the hole, then you still have this whole apparatus here of pipes and rubber coupling with your vacuum sensor, vacuum release valve back on the inside. That can still have a possible potential leak because you do have several clamps involved in here. The also have the valves here. These valves are not your defrost valves. They look a lot like them, but these are your switching valves. So when you're moving from max cold to a regular mode, like a program, these valves will flip, and that's what changes the gas flow from the collector up to the shelf. And then whenever you are out of max cold mode and the machine transitions into its next segment, the valves will flip back and that'll force the gas to go back down into the collector. Few cases I've seen a valve stick that help hurt the temperature on the shelf. You would get a partial temperature on your collector. Shelf was colder than what it was supposed to be because it was sharing the gas between the two. But you can always hear the valves very quickly by, this one is for shelf, this one is for collector, and these are the valve wires. So when you're in max cold, you can take this connector and just disconnect it, and you can hear that valve clunk, close and open and close just by plugging it in and disconnecting it. You can hear that valve move. And if you go into your standard mode outside of max cold, do the collector, you should be able to hear the collector valve open and close repeatedly. It's pretty loud when it happens, so it's easy to hear it. But if you're not hearing that movement, then you could have an issue with your valve. Then you have your Lexol tank along the side. Normally this has a pink color to it, but this unit has had some age. But we put pink in the Lexol so that it can fluoresce whenever you shine a black light on it, it'll glow like a light green. But your Lexol level, even though this is only halfway down, it's not a bad level. Normally it is filled all the way to the top. But if it's down here, it's not physically using this fluid during the system unless you have like a leak someplace. Lexol has a bad odor to it, so it's easy to smell. But as it cools, the Lexol level will go down because Lexol shrinks when it gets cold, but then it'll come back. So that's why you never fill the tank while the unit is cold, because then when it warms up, it might overflow the top of the tank. If you have air in your system, air within the shelf or in your lines anywhere for the Lexol system, even back to the pump, it should have no air. But if it does, you'll know it because you'll have a much more fluctuation of the Lexol level in your tank. It might go all the way down to the bottom whenever if we have air within the system. That air will compress and it'll move throughout the system, but your Lexol level will go down. And then as soon as you turn it off, the Lexol level will rise back to where it normally was. Issue with that, having air in the system, is that you're no longer having Lexol flow. So your shelf is not going to cool like it's supposed to at that point. So that is the chance to bleed the air from the system. There is a king valve right here on the unit. Has a little black cap on it. You just take that off, and there's a little square fitting on top of it. There is a special tool to open and close that with a square type wrench. I have used pliers before in the past. That's just something you don't want to do too often, because you can really scar up the top of this valve. This fitting comes off. This is a 3/8 flare nut fitting, exact same fitting as you have on refrigeration lines. All you need is a hose that's maybe a meter or two long. You attach it to this port, take the cap off of your Lexol. It just unscrews on top of here, and you put the other end of that hose back in top of your tank. Then you set the shelf temperature to plus 24°C in a manual mode, and the unit will then pump Lexol from this valve to the tank. And then as air flows through that, the air will escape through the tank. So it's an easier way to try to get that air out of there. And if this level starts to go low, you don't want it to go dry in this tank. You want to continuously keep it full. So you just have to add a little bit of Lexol as you go if that becomes a problem of temperatures on your shelf. Next thing is just taking the whole wrapper off, because this would be where you would. Well, here's your pass through again on the back, as we saw on the inside of the chamber. Pass through goes all the way through, and this is your temperature wires coming through here. So if you ever have an issue with a temperature sensor showing dashes, it could be unplugged from the front, where I was showing how the customers can sometimes pull that out of there. But then also have other connectors, like on the pass-through, where the wires can get pulled out of their connector there as well. With our temperature sensors, they all share a common ground. So when one sensor gets grounded out, they will all show grounded out, or some fashion of one might be dashes and another sensor has a reading on the display, but then that number isn't moving. It's kind of stuck in place. Then you'll have an issue with one of the 3 temperature sensors on the unit grounding someplace, usually in a wire that's become loose, or it could even just ground out directly in the tube that the sensor is in. Unplug them all, plug in one at a time, and make sure that one is working. And then you can do the same with the other 2. You can just plug it, remove them, and then plug them into even your sample port in the front. To take the sides off, we just have Phillips head screwdrivers on top, Phillips head screws on the side. The ones on top are a different thread than the ones on the side, so you don't want to mix those up. they look a lot different as well. So it's not hard to, it's easy to differentiate between the top screws and the side screws. Those are the two top screws. And here is one of your side screws. So they look a lot different, but get in a hurry, sometimes you might change them and they are not the same thread. So the sides and the top have grooves in them. And you can see along here, it's got a little groove there that then interfaces with this groove here on the front panel. Helps keep the panel nice and tight to the front and seamless without having to use screws. But when you're putting it back on, you just got to make sure you fit that back together, or you're going to have a gap on the front. Side is the same way. There are normally 3 screws on each side. But again, for time constraints, we removed 2 of them. This one comes out just like the other one did, has that groove in there. And then the top just slides off, because it as well also has a small groove right inside here. Right there, you can see that groove. Now it fits with the top panel up here. And if you were needing to adjust your hinges and how tight the hinges fit from the door, you see back here in the corner, we have these little slots cut out here so that you can get a screwdriver all the way back to those hinges there. You only loosen the hinges, or loosen those 3 screws. You do not remove them. The metal portion on the inside that has the threads in it may actually fall down if you remove the screws all the way out. So you only leave those screws just loose. And when they become loose, your door will go in and out a little bit. The holes in there are slotted, so as you loosen them, this part of the door will slide in and out just a little bit. Turn on the vacuum pump, latch your door completely, the door's latched, and push on the front door panel until your vacuum takes hold. Once your vacuum pump is pulling a vacuum on that door, it's going to close it much tighter than you'll ever be able to push it. Once you get a reading on your display, then you just simply tighten up those 6 screws on the side. To get to those hinges, you don't have to take it completely apart like this, but you do at least have to get the back panel off and the right side panel. And you also have to take the control panel off, because the screw that holds the side panel up here is the same screw that holds your front panel on. So remove at least this screw. Don't have to do the entire front panel. This screw, the rear panel, and the side, and then you can get to those hinges on there to adjust those. I don't think there's anything much else. The stopping tray jar is not a speed demon on cooling. It's got a collector that goes to -84, but the shelf will reach -55. But the IQ/OQ on that is 5 hours. There was an update to the system not that long ago. We made the refrigeration a little stronger, could put a larger compressor in on the second stage, and that has helped tremendously with speed. But our IQ/OQ is still at 5 hours. Now, usually the units can get to full temperature, usually within 3 hours now. However, we still left that IQ/OQ on there to give us a little wiggle, little a cushion there on the time on trying to make temperature on the shelves, because there's a lot of environmental conditions that can change within our labs. Some places that don't have as good air conditioning, these units will not work great in a unit or in a room that is hot. So if it's over 23 C, if you start getting into a room that's 25 to 30 C, the unit is not going to function as well as it should, because it can't remove all. Now it's having to dry your samples and hold a load there, and it's also holding a load from the room, is how hot it is. It can't remove the heat. So make sure your rooms are good and cool to be able to operate them very good. Anything else on the Triad? That's about it on the Triad. Again, if you have any questions on refrigeration or anything related to anything we're going over today, just make sure you make notes of those questions that you have, and then we will address those from your regional managers for that. So next we would do is the CentraVap. I know that's been some questions. Try and make some room here on my work surface here. If you want to bring the camera over here, Kurt, I was going to show a few things on the CentraVap itself. So the latch obviously is something that we have seen, but we have addressed that. But to see if the screw or the latch is working, it's pretty easy to do. You don't even have to turn it on. You actually have to turn the power on. But if you just do a little flick of the shaft, you might be able to see it down here in the hole of the latch moving just by me turning that shaft. You don't have to have the unit on or running or spinning or anything to know that's going to do that. Just open the lid, slight little turn of that shaft, and you can see it move. It should be just as simple as that. Should move very easily. But if it doesn't retract back, this unit uses a solenoid to pull the latch back. But whenever you hit run for it to go forward, you can hear the cooling fan on when you're in front of the machines. But as soon as you turn that rotor or turn that shaft just a little bit, you'll hear the cooling fan stop, and it ends up. Sorry, our camera got a little stuck there. There we go. Now we're unfrozen. So you can hear the cooling fan quit, because that's when the latch is getting ready to close. And you don't even have to have the button pushed in the bottom. If you did that, that would make the whole rotor and everything move. If you just had a small flathead screwdriver and you had your lid up, you could push that button in the bottom if you want to truly see if the rotor is going to turn, but you don't want to have anything in it. Take the rotor out, leave the chamber empty, push the button down with the screwdriver, and then hit run. It says lid latching, rotor's turning, and there's a valve that's going to click, and that's going to turn on the vacuum pump. So obviously the pump's not going to pull the vacuum with the lid open. But as soon as you let go of that, it's going to stop and realize that the lid is not closed. Or even if you try to start it, it's going to tell you close the lid, because that button in the bottom is not pushed. So if you have a closed lid sign and your lid is closed, then the button part of the switch is broken. It needs to be replaced. But these are all just tips on how to troubleshoot that latch. Now, while the unit is spinning, if your customer's ever wondering how much RPMs there are, when the unit is running, You can see how fast the RPMs are going just by pressing and holding the preheat button. Every unit has that. As you hold it, now your display changes to the RPMs. Looks a little weird on the screen through that, but it says 1710 right now, and gives you RPMs. Now on your 50 hertz units, I think the max is only 1400 or 1450, but here in the US on our 60 hertz power, we can go all the way up to 1800 RPMs. Once the heater is on and the bearings get warmed up, it'll spin a little bit faster. We're not too concerned about the speed of the condenser or of the rotors, because that's only there to keep the samples within the tubes as it's spinning. And if you don't spin and you apply a vacuum, then you're going to boil those samples and take them out of the tubes. That's why we have the rotation. Something that has come up every once in a while on drying samples when customers have an issue with microcentrifuge tubes. So if you had a rotor with microcentrifuge tubes, and for example, they had 10 samples in there, 4 of them dried, 6 didn't. Well, that's not really physically possible because they're in the same environment of a heated chamber, they're being applied by the same vacuum. So again, the CentraVap is doing its job because it's holding a temperature and it is holding a vacuum. But there's something else in play that is, keeping those samples from drying. So what we have found out from testing ourselves with microcentrifuge tubes, the little plastic ones, they come in a bunch in a bag. Usually people are grabbing them right out of the bag, putting their samples directly in them, putting them in the unit. But if you're going to say that out of 10 samples, 4 dried and 6 didn't, that's the same thing of taking 10 cups of water outside, being affected by the same sunlight, and only 4 of them dried and 6 didn't. It doesn't make a lot of sense. So what we looked at was with the tubes themselves, they're plastic molded. They come out of a mold, and there's got to be some kind of release agent that they have in those machines that allows those tubes to come out of their molds. They may just blow air in them, they pop off, but I'm not in that many. I don't know how those are manufactured exactly, but what we found is that if we rinse the tubes with alcohol ahead of time, and then we tried our experiments again, the same tubes that didn't dried just fine. I've had several customers have that, and when I tell them that's what they need to try, they think I'm just giving them work to do, but they come back later and said thank you, as they would have never believed it if they hadn't seen it themselves. So it is something that happens. It's not very often, but if that's what you're hearing from a customer, have them clean their tubes before they use them, or try a different bag of tubes. There's some kind of contaminant in those tubes anyway. Okay, on these units, we'll take it apart. I'm going to take the lid off here so I don't close it. The lid just comes apart. These little pins holds it in place. They come out. You might also get with lids that maybe are glass lids. This one here is an acrylic. But with these lids, there is also a spacer right inside here. And when you get a new CentraVap, sometimes you'll have squealing or squeaking when you first turn on the vacuum pump. It's usually going to be caused because this spacer is metal, and when you cut out metal that thin, it may not be as completely flat as what it could be. So it might hold the gasket up a little bit. That squeaking is just the air coming underneath the gaskets. It usually goes away after a few runs, few tries, and that spacer will flatten back out on its own. Just applying a hand, maybe a little hand pressure on top of the lid while it's on the machine. You're just pushing it down just a little bit will get rid of that squeaking. But it's not a running issue. It's just the machine needs to be a little bit broke in with that little spacer there. But we have also seen a few on the glass lids. The glass lids, this U-shaped piece is welded to a plate. It doesn't go through the acrylic or through the lid like it does on an acrylic unit. We've seen that spacer overlap plate that the U piece is welded to. And if it overlaps it, it's just by the thickness of metal. it might hold the lid up high enough to where you start getting closed lid signals. It's kind of intermittent because it's really close to having that button pushed all the way down. But so sometimes it'll work, sometimes it won't. If it's a glass lid, check out the lid. That's probably where your issue is actually going to be at. Make sure that spacer is not overlapping the plate. Okay, these units are not difficult to take apart. There's several screws to them, but it is fairly easy to come off. Really just need your drill, Phillips head screwdriver, and since these units don't have any refrigeration in them, at least this one doesn't, I can tilt it any way I want to, and it doesn't really matter. Nothing inside it's going to move or turn or come loose. Now, if you had a refrigerated unit, obviously you wouldn't want to do that. But there are 3 Phillips head screws up underneath the front edge. Set the unit on its backside. Most of the issues you find with the Centrovap would be either that latch or with the bearings. Customers will buy the non-acid resistant unit and they'll use acids like acetic acid, something that's not really that you would think of as being corrosive. Doesn't hurt the chamber or hurt the rotor, but it is not good on the bearings. So you can wear out the bearings. So you can get an alarm on this machine that says motor air, but I'll tell you that it is never the motor that is the issue. I do get customers that want to buy a new motor because it says motor air, and I'll tell them that is not their problem. The problem is going to be the Hall effect sensor underneath. That's what measures the rotation, the RPMs of the shaft. But if this is hard to turn, it should be very free. I should be able to turn it and it just spins and spins without much issue at all. But if you're turning this slowly and you feel any sort of resistance or some crunchiness to it, heavy sounds, that is bad. There's something in there. It might even have glass that's in the bearing. But this is not spinning at the proper RPMs, and that's why it's throwing motor air. So it can either be from the bearings or the Hall effect sensor itself. On a refrigerated unit, you can see that on a, if you get condensation underneath the chamber, you can get that to happen getting into that sensor. We now coat it with RTV to keep it more waterproof. On your ribbon cables, the shiny side is always pointing at you. The other side is just black. You can't see the pins. But on this side, you can actually see the pin connectors. And this always faces the front. That's how you know that that's in the right spot, because you can put it on backwards. But shiny to the front. On this unit, on this ribbon cable, is just, it's not twisted. It should be completely straight. Not twisted when it connects to the front side. We also put a line on it ourselves, making it easier to know which way it goes, but that will not be on the harness of all the units. That's just something we did with a marker. On the inside, we have some 3/8 nuts on the sidewall. You just have to loosen them. You do not have to remove them. The holes are slotted on the shelf. The shelf is there to help protect the PC board from debris or anything that might fall down on top of it. I'll take this time to pull the wires off the power switch. But then this just slides out of the unit. Set it to the side. Also, I forgot to note that on the back of this panel, it also has the wiring diagram as well. Again, several part numbers and pieces on there that you can use on that. And the wiring diagram also has its own part number. So again, if you need a bigger version of the wiring diagram, give us this part number that's on the sticker. We can find that faster. or just tell us what unit it is and we can figure it out, which wiring diagram is for that. Inside the unit well, I need to undo my wires a little bit here from the PC board. There are a couple of more 3/8 nuts that holds the control panel on. They're up here in the top, one here on the side. On this side, there's also one here, and then there's another one that's up kind of above where the cooling fan is. I'll grab that as I can see it. And again, just loosen, do not remove. You can remove them, but that's just something else to remember where they go. Since the holes are slotted, it slides right off. And here comes your control panel. On the inside again is that latch mechanism. When you hit the, when you put your screw through this little safety hole in the side, you're hitting this little lever here, and that's how you know it should be very free, shouldn't stick at all. The way the unit knows that the lid is closed, besides that switch, it also has an optic eye, which is part of the latch here. It either sees its reflection or it doesn't see its reflection. It might be hard to see on the camera, but there is a black painted piece right here on the steel so that it blocks the optical eye. And then here, opened, it sees its reflection from the shiny metal. So that's how it also knows that it's open and closed from that optic eye. Taking the wrapper off, just go to the back of the unit and use the drill. We'll get these screws out a lot faster. I have seen the lid brackets up here. I've seen these pins break off of this piece. This is pressed into this metal. So the only way to replace it is to get that assembly. We put in a little machine that presses it in for us. And these have nuts on the bottom side of these screws. That's how they come off. Might be hard to get in there and see it. See those up in there? Might not be. But there's a couple nuts on the back side. So I've also seen the lids rub on top of these screws before. And it's probably the nuts that are loose. The brackets are down further than they're supposed to be. Tighten those nuts, it'll lift these brackets up and it'll raise that lid to the right height it's supposed to be at. Now on the sides, this back panel has several wires in it, but it can just sit like that. It's not gonna hurt anything. Take off your 4 on this side. Tilt it a little bit more. Now you can get the 4 over here. Teamwork here. Then there's a ground on the front that I just remembered as well. Right next to the power switch, there's a ground wire. There's 3/8 nut. That one you do have to remove to get that ground wire off of there. And I like to put the nuts right back where I got them so I don't lose them later. Okay. So now the wrapper is going to be able to come off, and you still have this little valve here on the side. This valve here is for measuring vacuum pressure. There's a little hose barb that comes with each unit, and you stick it in here and it opens the valve. I've seen customers have an issue with their drying. They're getting maybe condensation on the lid of the unit, but it's because they're losing vacuum someplace. And I'll ask for pictures of the unit and I'll see the hose barb sticking right in the side. A little small piece, they didn't want to lose it, so they stuck it in there for safekeeping, not realizing that they're opening up a valve and now they're sucking air through that valve. and that hurts your vacuum pressure. You want to pop that out. It's just a little push of the button and the valve comes out of there. But that piece is used for attaching a vacuum gauge if you need it. Or we also have a vacuum controller if you're using a diaphragm pump, and you can control the vacuum with it as well. It has a little dial on it and a gauge, so you can dial that in, the pressure. You really only need pressure of about 10 to 15 millibar. You do not need to use rotary vane pumps on a CentraVap. It is a lot of pressure. You can actually freeze the samples if you apply too much pressure, and then the drying is really slow. So a diaphragm pump is really all you necessarily need to have, unless you have customers. We have some that like to use their freeze dryer as their cold trap, and they use the CentraVap too. So they'll use a rotary vane pump, but you just got to watch out for how much vacuum you're applying to it. So to get that unit off, that valve goes right through the hole on the side here. It's sometimes pretty tight getting it through there, but enough angles and you can get it around that valve without taking it off. Now we're down to the whole chamber, and we need to start removing it, but we can also remove some of the wires connecting here as well. This is a little bit of an older system, so it has some wires onto its vacuum release valve here. So I'm just going to remove these from the vacuum release valve. This is a band heater on this unit, so it has an extra, it's for preheat, but it comes on to make it faster for heating. We'll remove these wires from the relay. It's always good to take pictures of all your wiring ahead of time so you know where everything goes before you take it apart. But you can also look at the wiring diagram and figure it out as well. And there's some that go to the heater coil up underneath. You have the heater terminals right here underneath it. Pull those wires off. And if you turn the unit on its side, got these 4 screws here that allows us to remove the chamber completely. Few more wires. This is a thermal overload protector. This was a single blow kind of thermal overload back then. If this popped, you had to replace it. Today's models has a thermal overload that is resettable. So once it cools off enough, it'll reset itself. Now let's see. We also have a wire here. That's good. And my ground wire still connected here. You can disconnect the ground on either side. I like doing it from the bottom of the chamber, just so I don't have extra wires laying around where I don't know where it goes afterwards. Wires, hook the motor. Okay, so those are the motor wires there. So now we're down to the chamber itself. Turn it over. Here's that motor. Again, doesn't have any issues, so you never have to replace it. I'm going to change to my Phillips tip. Now, I would recommend using a drill, or not drill, but a hand tool, just so you don't strip out the screws. We also take the time to mark the bottom of the chambers, so we know we're putting the brackets back in the same direction that we had it on originally. We'll mark the thermal overload. We'll measure or mark the temperature probe. That's what TP is for. Hall effect sensor is what some of these are for as well. And this was GR, was for your ground wire. Screws are a little tighter. these come off. And on the back side, I'm going to take these screws out. Here you see the magnet that drives the shaft. The shaft does not have direct connection to the motor, it uses magnets. The magnet here goes through the seal plate here on top of the chamber, and it interfaces with another magnet that's on the other side that's attached to the bottom of the rotor or of the shaft. And to get to those, we can see it. The temperature probe and the Hall effect sensor are together. This is in one piece. The little black is your temperature probe, and then this ends up being your the piece that detects the rotation, the RPMs of your rotors that's spinning. And we have two more screws here that's going to hold in the rotor or the bearing assembly. This one as well. I'm holding the shaft on the other side so it doesn't fall down while I'm doing that. But inside, you have your heaters, you have your seal plate. Underneath the seal plate is where we will have that other magnet. So mix them up with those others here. There, the seal plate comes off, has some vacuum grease underneath it too. These O-rings have vacuum grease on them. It's just a little plate with no metal inside it so that the magnet can work its way through it to get to the magnet on the bottom of the shaft. So if you end up with some bearings that are worn out and need to be replaced, you get this whole piece minus the heater and the O-rings. You do need to reuse those from the old unit. But you'll get this whole piece with the hub and the shaft, magnets already attached. This one just mounts straight to the bottom of it. The magnet that's on the motor has a certain gap between it and the bottom of the seal plate, which is about 0.03 of an inch. It's pretty small. But it's big enough that you might even have a chance of getting metal burrs from screws or something like that might stick to the magnet. That's why we have these little acrylic plates on the side, keep stuff from getting into that area on the magnet. Other than that, that's about the only thing you'd ever get with the motor being stopped with anything that might get in the way in between there. So that is the complete disassembly of a standard Centrovap and a -105 4.5 liter and a Triad. That was very fast and very quick to try to cover all that in 2 hours time. We have maybe 10 minutes left of that, but that is all we have for the class. Really appreciate everybody attending. Hopefully in some of those countries, I know it's early mornings where you're at, and you stayed awake through the whole thing. Well, we appreciate everybody attending and everybody paying attention and watching, and hopefully things you saw today will help you better your customers and help service your customers. Again, if you have any questions, please make note of those and hand those to your regional managers, and then they will let me know so I can answer them back for you. So thank you, and good night or good morning, wherever you're at. Thank you. Bye-bye.